Hello guys, I'm Karthik SP from SPC and today I'm gonna video present maths assignment. So let's start. So my topic is regression analysis, lines of regression and its applications. So I'm gonna cover topics based on introduction, briefly explain what regression analysis is, mention its significance in various fields, definition of simple linear regressions, y is equals to a plus bx, explanation of intercept and slope, definition of multiple linear regressions, formula y is equals to a plus b1 x1 plus b2 x2, explanation of coefficients, linear assumptions, independence of errors assumptions, homodiscacity of assumptions, normality of error assumptions, r squared, adjacent r squared, mean squared errors, f test and p value, interrupt and intercept and slope in a regression module, briefly demonstrate how to perform regression analysis in MS Excel, economics and finance, marketing and market research. Basically, it's used in medical research, social science, quality control and process optimization, sports analytics, risk analytics, explain the specification application in more depth, provide real world examples, choose an interesting case study from one of its applications, research questions, data used and results, limitations and challenges of regression analysis. So its importance is in address potential issues with causality versus correlations, recap the importance and versatility of regression analysis, summarize the application and benefits. So linear regression is used when there is a linear relationship between dependent variables and independent variables. Multiple regression extends linear regressions to situations where there are two or more independent variables. Is a fundamental statistical technique used to explore the relation between variables, uncover patterns, and make predictions. Is widely employed method in various fields, including economics, finance, and social science, medicines, marketing, and more. Also known as the regression lines or best fit lines, are used in simple linear regressions and multiple regression models. To summarize it and represent the relation between dependent variables, one or more independent variables. Formula y is equals to a plus bx. Y is an dependent variable, x is an independent variable. A is the y-intercept value of y when x is, b is the slope of line representing the change in y for 1 unit change in x. Next, predictive modeling regression analysis is used to predict values based on historical data and enabling business to make informed decisions by fitting lines of regression to time series data. Trends and pattern can be identified and used for forecasting as well. Regression analysis helps establishing cause and effect relationship between variables, aiding research in understanding and impact of specific factors. Regression models can identify and quantify risk factors such as in finance as well as insurance industries, assist in understanding consumer behavior, marketing trends, and demand forecasting. Mm, Explain what is regression analysis. Simply linear regression used when there is a uh, linear relation between one dependent variable and one independent variable. Multiple regression used when there are two or more independent variables, allowing us to examine the joint effect of multiple factors on dependent variables. Economic and finance. It's basically its significance in various fields used in economic and finance, in social science, marketing and market research, business and management. So in economic and finance is used when in economic modeling to study the relationship between various variables such as GDP, inflation, interest rates, and unemployment. Social science, socially, physiologically, and other social science regression helps the research case study the relation between variables that affect human behavior. Regression is employed to analyze customer behavior, understanding market trends, and predict demand for products or services. Regression analysis used in business analytics to study the relation between various business factors such as sales, cost, and profitability. Mention its significance. It's used in medical as well as health science, environmental science, engineering and technology. Widely used in medical as well as health science is widely used in medical research to identify risk factors such as disease, effectiveness of treatment, and predict health outcomes. Environmental science, relationship between environmental factors such as pollution levels, climate variables, impact on ecosystem and human health. Engineering and technology, applied in engineering to model the relationship between different variables such as stress and strain in materials and to optimize the process and design. Education, as well as quality control and manufacturing in real estate. In education, it's used in to study the relationship between educational variables such as teaching methods, performance, and school funding. In quality control and manufacturing is employed in quality control to identify factors affecting product quality and to optimize manufacturing process. Real estate to industries regression analysis used to predict property prices based on various factors like location, property size, and amenities. Simple linear regression. Y is an dependent variable, X is an independent variable. A is the y-intercept value of y when X is. B is the slope of the line representing the change in y for 1 unit change in X. Application of simple linear regression. It's used in predictive analysis, trend analysis, causality, correlationship measurement. So in simple linear regression, it's commonly used for predicting models by fit as in trend analysis uh, to, to, to time series data trends and pattern can be identified for forecasting future values. Causality assessment between variables which can be used for future researches. Correlation measurement is the correlation between the dependent as well as independent variables. Definition of simple linear regression. Y is an independent variable, X is an independent variable, A is a y-intercept which represents the value of y which is axis, B is the slope of the line which indicates the change in y for 1 unit change in x. So the formula y is equals to a+bx. In that y is a dependent variable, X is an independent, A is the y-intercept which represents the value of y which is axis, B is the slope of the line which indicates the change in y for 1 unit change in x. Explanation of intercept and slope. Intercept is the value of the dependent variable when the independent variable is. A slope represents the rate of change in the dependent variable for 1 unit change in the independent variable. Multiple linear regression. Y is dependent variable, x1, x2, so on up to xn are the independent variables. A is the y-intercept represents the value of y when all independent variables are. B1, B2, so on up to Bn are the coefficients of the respective independent variables. Change in y for 1 unit change in x variables holding other variable constants. E represents the error term accounting for partiality not explained by the model. In business and economics, used to analyze the impact of multiple factors or on business performance. Marketing research helps in understanding how various marketing variables influence sales and consumer behavior. Medical and health science is employed to study the relation between health outcomes and multiple risk factors. Social science used to analyze complex relationship between multiple variables in sociology, physiology, and educational research. Finance used to study the factors influencing stock price, asset returns, and investment decisions. Environmental science helps analyze the impact of multiple environment factors on economic systems or human health. Engineering used to study how various engineering will affect product performance, process optimization, and design. Multiple linear regression used in real estate. Uh, Multiple regression can be applied to analyze factors influencing property prices, location size, and amenities. Definition of multiple linear regressions. Y is an independent variable. X1, x2, x1 up to xn are the independent variables. So y is the dependent variable. A is the y-intercept represents the value of y when all independent variables are. B1, B2, so on up to B1 are the coefficients of the respective independent variables. E represents the error terms. Y is the dependent variable. X1, so x2, so on up to xn are the independent variables. A is the y-intercept represents the value of y when all independent variables are. Definition of multiple linear regressions. B1, B2, so on up to Bn are the coefficients of the respective independent variables, indicating the change in y for one unit change in each x variable, holding other variable constant. Uh, Explanation of coefficients B1, B2, B3. Coefficients of B1 represent the effect of first independent variable x1 on the dependent variable y. Coefficient B2 represents the effect of secondly independent variable x2 on the dependent variable y. B3 and so on similarity. B3 represents the effect on the third independent variable x3 on y and so on for all the independent variables. Assumption of regression analysis used in assumption in linearity, independence, homodiscacity, normality, no perfect multicollinearity, no autocorrelations. Relationship between the dependent variables and independent variables is assumed to be linear. Observation in the data sets are assumed to be independent of each other. Variance of residual should be constant across all levels of the independent variables. Should follow a normal distribution, meaning that they should be symmetrical distributed around zero. Independent variables should not be perfectly correlated with each other. Correlation refers to the correlation between residual of a regression model. No endogeneity occurs when there is a two-way causal relationship between dependent as well as independent variables. Determines which variable is causing the change in the error. Linear assumptions, homodiscosity, independence, normality, no perfect collinearity, economics and finance. Uh, Dependent variables and each independent variable is assumed to be linear. A residual should be constant across all levels of the independent variables. If the data set should be independent of each other, should all follow a normal distribution, meaning that they should be symmetrical distributed around zero. No perfect multicollinearity. The independent variables should not be perfectly correlated with each other. Economic and finance modeling cost prices analysis financial data. Linear assumptions of regression analysis in marketing and market research used in social science, medical and health science, engineering, environmental science, employed to predict sales, understand customer behavior, and optimize market strategies. In social science, applied in sociology, physiology, educational research to study the impact of variables on human behavior and outcomes. Medical and health science used for medical research to study the relationship between risk factors and health outcomes. Utilized to model and optimize process, analyze engineering data, and make predictions in various engineering disciplines. To analyze the impact of environmental factors on ecosystems and human health. Quality control and manufacturing used to assess the impact of factors and product quality and to optimize its manufacturing processes. Next, later we have independence of errors, assumption of regression analysis of regressions. It's in residual plots, Durbin-Watson test, Legends box, Brissets Godfrey test, time series analysis and spatial expression. So in residual plots against the predictable values or the independent variables can help identify any patterns or trends in the residuals. Durbin-Watson test is designed to detect the presence of first order autocorrelation in the residuals. Legensing box is a general test for autocorrelation in time series data, and Briss's Godfrey test is used to detect higher order autocorrelation in residuals. Time series analysis essentially to check for autocorrelation in the residuals as time-related patterns. Spatial regulations, spatial autocorrelation should be assessed to ensure the independence of residuals. Longitudinal studies as well as experimental studies where same subjects are measured independently over time. Assumption of independence of error is crucial. It is important to check for any signs of autocorrelation in the residuals. Homodiscacity assumptions in analysis lines and regressions are residual plots, scale location plots, Brissett patterns test, economical data, social science. Against the predictable values or dependent variables can help identify any patterns in spread of the residual in the spread of the residual. Scale location plot, the square root of the absolute residuals against the predictable values can reveal any systematic pattern in the variance of residuals. Is a formal statistical test to detect heterodiscacity. Economic data is essential to check for homodiscacity to ensure the validity of the estimated coefficients. In social science involving social or physiological data, heterodiscacity can affect the conclusion drawn from the regression results. Is used in market research, engineering, data transformation, as well as weighted least squares. Homodiscacity is important to make accurate predictions and assess the impact of marketing variables. Engineering to ensure the reliability of regression models used for process optimization and quality control. Mathematical function may help stabilize the variance and make the residuals more homodiscacent. Um, WLS weight least squares is a method that assigns different weights to observation based on variance, giving more weight to observation with lower variance. In homodiscacity assumptions, robust standard errors approach adjustment the standard errors of the regression coefficients to account the homodiscacity. In normality of error assertions, we have a histogram, normal probability, stereo will test, hypothesis, confidence intervals, prediction intervals. Histogram residuals can provide a visual representation of the distributions. Normality distributions, these are the residuals against the qualities of the standard normal distributions. Stereo will test to access the normality of the residuals. Hypothesis normality assumption is needed to compute accurate p-value and make correct decisions based on statistical significance. Confidence intervals around regression coefficient relies on the assumptions of normality to provide reliable estimates. Prediction intervals to construct accurate prediction intervals of the dependent variables. Statistical interference, data assumptions, data transfer, robust regressions, as well as non-parametric methods. In static interference is the fundamental assumptions in various statistical interference procedures. Data transformation mathematical function may help the residuals more normally distributed. Robust regression estimated even in presence of non-normal errors. Non-parametric methods distribution of errors can be used when normality is not met. In R squared, coefficients of the determinations measure the proportion of the variance in the dependent variables and is explained for dependent variables including the model. Mean squared errors is the difference between observed values and predictable values in the regression model. F-test to assess the overall significance of the regression models. Economic and finance and analyze the relation between economic variables and predicting stock prices. Later, in normality of error expressions, we have marketing and market research, social science, medical and health science, engineering, environmental science. Uh, Market and market research analyze the impact of marketing strategies on sales and predict market trends. Social science, the influence of variables on human behavior and outcomes. Health and medical science, health outcomes to predict disease outcomes as well. Engineering is utilized to model and optimize the processes, analyze engineering data. Environmental science to analyze the impact of environmental factors on ecosystem and human health. Later, interpretation of regression coefficients. Why is the independent variable X is the why is the dependent variable X is the independent variable? A is the intercept which represents the value of y in X. B is the slope which indicates the change in y for one change in X. Later regression analysis in Excel, input of y, input of x, out range, selects the y value in column B, selects x value in column A, where you want to output range, where you want to regression results to be displayed. Brief demonstration of how to perform the regression analysis in MS Excel. Click on File Exit ribbon, select Options. In the Excel option dialog box, add-ins, manage box we have, then check the analyze tool pack, Input Y range, input X range, check the labels, intercept the value of the salary when years of experience, represent change in salary for 1 unit increase in years of experience. Later we have briefly demonstrate of how to perform regression analysis in MS Excel. We can use it in economics and finance, financial modeling, demonstrate analyzing. Brief demonstration of how it is used in MS Excel is used in market and market research, pricing strategy, market effectiveness, um, medical research as well as social science, quality control and process optimization, application of regression analysis used in economic and finance, market and market research, medical researches, as well as we have limitations of regression analysis, discuss the challenge of regression analysis, address potential issues, linearity assumptions, outliners, multicollinearity, autocorrelation, homodiscacity, limited extrapolations, causality versus correlation, experiment design, causal interference technique, longitudinal studies, replication and robustness check, theory and contextual knowledge. Later, we have its importance and versatility. Versatility. It's used in quantifying relationships, predictive modeling, hypothesis testing, control and adjustment. Model interpretation provides interpretable coefficients, aiding the understanding, imaginative and directive of the effects. Application and benefits used in economic and finance, marketing and businesses, social science, medical research, social and public policy. And at the end, we have the conclusion part. Regression analysis is an essential and versatile statistical tool that plays a crucial role in various fields, from social science and economical to engineering, healthcare, and beyond. Its importance is the ability to quantify and understand the relationship between variables, help research and practitioners make informed decisions, predictions, and policy recommendations. Significance and versatility as well as applications benefits are used in it. So this is the end of the slide. And today and from here I'm gonna end my maths assignment session. Thank you. Have a nice day. Bye.